Hello, back again. Mounted all the switches, reasonably lined up, mounted all the LEDs, hopefully got all the positive terminals on the inside. These last two are, they call them watercolors or clear, but one's pink and one's purple, and that I didn't mention this in the last video, but that's a test LED that we can use later when we're trying to see if what's going on with the nano board in case we want to send a test signal. You can see that I've added a few more holes in case I want to expand this to up to 8 or 9 perhaps. I've got my switches, so if I want to expand this I just move the this switch over to here, but we'll stick with what we've got at the moment. So the next step is to mount the power harness for wiring harness. So the first thing I'll do is mount the jack in its hole. Now I'll mount the little switch first because that's on the inside, it's probably harder to get to. So let me just make a bit of space here. It's got its 2 panel nuts, so you can set the depth of the screw. I won't bother mucking around with that too much, and it's got a sort of spring washer. And mount that in there, like that. I'll come around and put a washer and the nut. You gotta be careful, especially with this really small hardware, and this is relatively cheap hardware. They don't take too much pressure. It just needs to be pinched up so it doesn't flop around. So there's our switch mounted there. Next, I'll mount the jack. This is one I salvaged from other projects, so it probably looks a bit used. I think they usually come with a washer. Can't remember. Alright, so we'll mount that there. That looks good. Mount it like that. Put that on there. Now I've got a socket for that. This time we'll use the other measurement, 5 giggles, no 5/8. The one that isn't metric, imperial if you like, imperialis. Yeah, that's amusing using those funny old measurements, isn't it? 5/8. Who would do that? Right, now what we need to do now is put the battery in, clip on the battery connector, 9-volt connector, and we have, when we're ready, we have some power to deliver to the Arduino board. Right, the other last bit of hardware is this 5-pin DIN connector with a couple of screws. I had to drill the flange holes out to fit these screws. I've got lots of these little ones, so I use them. These are slightly smaller. I don't know what size they are. They're probably about M2 metric 2mm or something like that. Maybe 2.5. Right, so this is pretty enthralling stuff. You put the screws in and screw them on. The nut in place and get it started. We'll get this one in place. Alright, we'll stop there. This is getting too frustrating to film and try and do. It's so fiddly. But you get the idea. Once I've screwed that up, all the hardware we need for this as a test bed is mounted. We've got power supply, we've got the board mounted, we've got the switches mounted, the LEDs, the DIN plug for the MIDI connection. So the next film we'll start looking at the wiring.
Just before the next content, there's a lack of continuity. Something was lost. So what's happened prior to this next video is the Arduino V-in and ground were connected to the power supply positive and negative respectively. If you go back to the picture of the board, you'll see V-in and ground are there together. I think in this video they're the purple and ground wires. I uploaded the Arduino sketch file using the USB connection, and I made some test connections for switch 1 and LED 1 just to see if it was working. Well, you can see I've got the plugs messed up a bit in this video, and the DuPont connectors were plugged in for the Arduino board for the LEDs. So really all this is showing is the process of wiring up from the control terminals to either the LEDs or the switches. And what's may not be clear here is that the switches are using a common ground and the LEDs are using a common positive through the resistors for their, and the other terminals are going to control terminals being D2 through 7 for the switches and A0 through A5 for the LED output power, and I think the reset button is also connected in there as well to an extra switch. So hopefully it makes sense from here.
Okay, I think my camera wasn't working when I thought it was, so I've switched my soldering iron on and I've connected in the DuPont 6-gang DuPont connector, and I was just talking about the need to put a resistor, which I'll put on which I just took off here while the camera's off, and I'll put on the positive terminal where the 5 volts come in. It's just to pull down the voltage to about the 2 to 3 volts that most LEDs want. So I'll just clip this off and use my handy tool here. Wouldn't normally do it like this over the work, but just to show what's going on. So you've got to tin everything. So I'll just give that LED a bit of a tin there, and on the other side. Take this one off. I'll put this one on. And come on. Gee, that stayed good, much longer than I expected. Just give that a bit of a trim off there. Off it goes. And I think I'll right, yellow one. So I'll cut these off right at the end. I'll cut them off here, so if I ever want to use this plug, that'll give me plenty to get there. I can always make some use of the this end. That one just separating the wires. Which I'm going to take that back to about there. All right, take it back to there. So right, that's going to be nice and neat if we do it that way. And I am connecting to the negative leg, which is here, which I know is already tinned up because I'm just going to push this over to route the wires. Oh, that looks good enough. So cut that off there. Use the wire stripper. That's good. Sometimes these things are so cheap, if that'll sit still long enough for me to tin it, that the wire strippers are too hard on them, and they just pull the wire, cut the wires off. All right. So I'm old. I need to take my glasses off so I can see what I'm doing. I usually have stronger light, but I'm doing it where I can film. Right, that's on. I'll check it all later if it's when I can be less old. All right, so if this is working, I'll just temporarily put this one back on. And this is the way I always have to do things. I'm just checking again if it works. Just stay on there temporarily. Right, I'm just going to switch it on. Okay, that's worked. So the next step, I'll switch that off again. The next step is to do the same thing on the other side, which is using this wiring gang. Now, looking at this side, you can see that that purple wire is connected to the ground, and my first turn this on again, and I should be able to switch it. There we go. We're getting that on camera? Yes. All right, so now I'm just going to rinse and repeat all 6 switches and all 6 LEDs, and we'll come back after that. Finish wiring the hardware for this unit, so you can see all the wiring from this side. We'll just turn it over. That I've wired in the 6 control switches, the reset switch, the wiring harness for the power supply and switch, battery, the 6 indicating LEDs. That's a spare LED. I haven't used that for anything. The 5-pin DIN connector for the MIDI output, and all the connections have been made to the pins in the Arduino board. So just looking a bit closer at the unit here, I'll just see if I can. Yeah, so each of these LEDs are supplying power to their positive legs with a pull down resistor of a 220 ohm resistor, not 220k. It's 220 R value, which is 220 ohm. You can see the bands on that resistor if you want to check the value. That's going to the positive leg of the LEDs. I've bent each leg over here for each resistor just to make a common connection, and that's going to this orange wire, which is going to a 5-volt output pin on the Arduino. When I turn it over, you'll see the pin labels and be able to make more sense of that. Also, I've connected 5-volt power supply to pin number 4 of the 5-pin DIN connector, and that's also pulled down by a 220 ohm resistor. The other pin number 2 of the 5-pin DIN connector is wired into a pin which is the serial TX transmit pin of the Arduino board, Nano board, and that's the to transmit the MIDI configured serial messages, signals coming out of there. So that's all. So that configuration is done on the software side, which we'll get to later. On the other side, the 6 control switches have a common, on one leg they have a common pin to ground, which is going back to, a bit hard to see because it's a bit obscured, but this purple wire here is going to a ground connection on the Arduino board, and the other legs are going to the control terminals for the switches in this gang of wires here. So these wires, this side here, are configured as inputs, and these are configured as outputs. The only other connections here are the wire is the from the power harness is the voltage in, the purple is the voltage in, and the grey is the negative in. So this board will accept 9 volts. So looking at the other side, just see if we can look at the pin layout and see what those connections are doing. So this gives you the front of this box gives you a description of the pin out. So what I've done is, you can see on the switches here, I'm using these connectors from D2 to D7 are the output connectors, the output pins. They're designated by the software, which I'll get to later. So that's these wires here. They're connecting to the switches. The ground wire is connecting to the ground switch, which is here. And the reset is connecting here, and the final pin, you can see TX and RX. That's RX is the receive serial, TX1 is to transmit serial. So the TX1 is a bit obscured under the, you see some obscured under the cable tie, but that's the TX pin there connecting. On the other side, I'll turn that over and maybe just put it like this. I'm using pins A0 to A5, and they're configured as output pins for the LEDs. A0 to A5, the LED pins. The last part of this is up this end. Sorry, I was going the wrong way. Up this end, which is the 5-volt out and the voltage in. So 5-volt out, you can see that's going to the common positive terminals of the LEDs, and the voltage in. So it's quite handy having that picture in the box to describe all the connections on this, because this is zoomed in. Try not to shake. This is zoomed in, and it can be a little bit difficult to read, but you look at it and you can see all the connections there. So just to show it in action, I'll zoom back out again. Right, if I turn the power on, when I turn the power on, it'll do a startup cycle just to show all the LEDs are working, with the exception of this one, which isn't wired in. And then I'll just show you the switching. All right, there it is, cycling through. They're all working. So as I push each switch, go back down. Okay, so they work. I'll just press the reset switch there. It just does the same thing as powering up. Now the reason I put a reset switch in is firstly for the test bed. It does the same function as this reset button here, but I prefer not to touch the circuit board if I can. But also when if you set up a standalone unit, like on a pedal board, you want a reset switch and you want it available to you outside the as a control, because you won't have access to the board itself to do it. What this is simply doing at the moment, as you can see, it's like a working as an array of switches that flip flop in a sequence. Oops, I could do that every time I push the reset button when I'm mucking around. Best not to have the reset button where your controls are. Okay, so what it's doing is the software is controlling how these switches interact with each other. So every time you press the switch, the software does a few things. It firstly says turn off all the LEDs, then tell me which of the switches has gone from high to low resistance, so it's making circuit to ground. And when you identify which switch it is, figure out what state that is. Is it in off or on? And that's a software flip-flop kind of thing, which it's easy to understand when we go through the software itself, through the sketch. And it says based on its current status, it'll do one of two actions. The first one, if it's currently on, like this one is currently on, then you don't do anything because you're pushing the button to do what the current state is, so do nothing. But if it records that you're pushing a button that is is a different make to ground to the one that's currently on, it'll turn off all the LEDs and then turn on the LED that corresponds to the switch you pushed. If you push that switch again, it'll say the current status, this one is on. You press it, it doesn't do anything because it says it's already on, so I do nothing when it's on. But if I change it to another one and so forth. So it's obvious, or it's a bit more obvious when you look at the software what is actually going on in the system. But basically, the board is in a constant state of looping. It's constantly looping through its software, and it's testing every decision point and every action in the loop every time, and it's just waiting for you to interrupt that loop with a different status, such as make to ground, to do the actions that relate to that. So that's the thing to see. You'll see in the software, but understanding that if it's in a constant state of looping, testing if anything's changed. That's how the software works. I don't think there's anything else. The only other bit of hardware that could possibly put in here is this is a micro USB connector, which is used to upload the software from the Arduino, from your PC, from the Arduino sketch editor. And I haven't got them yet, but I'm getting a micro USB to USB 2, I think it is. It's a square printer type connector. That's panel mount. So you can also mount your USB connection outside the for access outside a unit. So if you want to upload or update your software, it's easy to do. You don't have to pull it apart. Um, so I think that the next, well, I think I know the next videos will be looking at how the software code is structured and how it's uploaded, um, using a practical example of my own pedal board. One thing I forgot to show uh, is related to the MIDI output as to what's going on. So um, with the switches, which I just demonstrated how the switching and indicating LEDs work, but the whole thing is about sending the MIDI signal. So just one thing to try and observe, what I'll be doing after I zoom in on the board is I'll be pressing switches to try and show on the board there's a TX, a transmit indicating light. Just see if we can focus in on that. If you see, let me expand in. Right, you see I'll get my finger in there. You see just under my finger is the RX. We're looking at the TX indicating light there. When I press a button, you'll see that flash very briefly. I don't think that came out was too obvious. Let me get. You might be able to see it. I'll get right in close, as close as I can. There it is, flashing every time you press a button. What that's indicating is you're sending some serial communication, you're transmitting. So that's the indication that the MIDI signal, the serial communication MIDI signal as configured, is actually going out and being sent out that TX pin and the hardware connections through the 5-pin DIN to whatever unit you're trying to control. So that's the whole point of this thing, is to send MIDI signals. This is the final video on the test bed that we've created here and gone through how to physically set up the wiring and how the code is put together. And I'm doing this in parallel with setting up a practical example of this unit here, which is going to go on my pedal board and replace this arrangement here. So just quickly, my pedal board, the signal path, this just switches between two inputs for two different guitars, goes into the Nuix Matsume compressor boost. This also has an external control function where you can put a cable in there, TRS cable, and externally switch both those, which I'm going to use for the boost, not so much needed for the compressor. And then it goes into my Chase Bliss Automaton 2, which is a unit the unit that's controlled by MIDI. That's where I set up all my patches. Then into the Visual Sound dual tap delay, and the signal then goes out to my Dunlop pedal. Get rid of that piece of foam, and out to the amp. The other paths and switching is I use a Fender Reverb Deluxe reissue, so there's the amp switching for the reverb and tremolo. The visual sound set up for the stereo jacks. I don't use stereo, but one channel is going with the wet signal out to the pedal. The other dry signal is going to this tuner unit here. There's also a MIDI signal going out from the Chase Bliss Automaton to the MIDI 5-pin DIN jack. That connects to a Chauvet foot controller to control some stage lights that the MIDI
switching here is switching both this unit and sending a switching to the stage lights, which is, it probably doesn't really need to be done, but why not? I can do it for fun. Um, so I just want to demonstrate how our test bed is working to provide MIDI controls. So the first thing I'll do is I'll power up, and note that I'll explain what this is about with these LEDs, but everything's powering up here, delay on and off, that's all manually switching. Now I'll turn on the test bed. It's doing its cycle test for all the LEDs. Right, so what I'm going to do is, as I go through each of these switches, I'll try to avoid hitting the reset switch, which I just did. As I go through each of these, what it's doing is sending a MIDI signal out through that jack into the in jack of the Amp Pro control, and you can see it's changing the Chase Bliss unit for its presets with those very exciting motorized faders. 1, 2, 3, 4, 5, 6. So what it's doing is actually just directly replicating what this Ampro control unit, Ampro, who makes Hotone, Hotone. This does the same thing. 1, 2, 3, 4, 5, 6, 7, 8. This unit has two external TRS jacks for expression pedals, or in this case, you can set up dual switching units. So I'm using both ports to set up a couple of dual switching units. That works fine. This unit is excellent, absolutely for the price. It's fantastic. It has a great phone app for controlling it and setting up. Really intuitive. So I really like this unit. There's a couple of problems for me with it, which is why I'm going to be setting up this controller unit over here on this board, and that is I'm old and I like to wear very comfortable footwear, and I get fat foot syndrome where I'm hitting two switches at once, which is a problem because, as you can see from these arrows, which I put those on myself, but this can bank up and down. I don't use banks. I only want one bank, and I get caught out. Why you're playing a song, why it no work, and your brain doesn't work properly because there's too many things going on to realise that you've accidentally gone up to patch 1 where you should be at patch. Oops, pressing the wrong switches. You should be at patch 0, or you've gone down to 99, and that no good. So that's one issue. Is the switches are too close together, or I don't want patch switching. The other thing is it doesn't have LED indicating LEDs, which just takes away the thinking. When I'm playing live, I do some backing vocals. I sing occasionally. Um, my brain can only do so many things at once before, if something goes wrong, I don't have much time. Then your brain doesn't work. Even with the time you got, your brain won't work properly. So that's me. Maybe I'm just not. I'm too old. I'm not smart enough. So that's what's going on there. But yeah, still, I think this is a fantastic unit. Now with the relay switching, all it's doing is this dual tap delay has one first channel, a second channel. This is good because it's got a modulation control on it, which means I can use this virtually like a chorus. This has got a switch to make it manual, so it's not controlled by the tap. You see, it's got a manual mode, so it won't be affected by the tap. Whereas the second channel is controlled by the tap delay. This unit also has an external jack, TS jack, phono jack, to do an external tap tempo. And all I've done is, under this unit, is there's actually no Arduino Nano board in there and some relays to control tapping. So you'll hopefully hear the relays working. Fast, medium, slow. And all they're doing is, it's like a bit of a hack on this. All they're doing is the same thing as if you're hitting the switch at that tempo. So when it comes to this unit here that has 10 switches, basically it's going to replicate the 8 switches that are currently here. And this switch here is going to be the boost switch for using the external external control function from the Nux Matsume boost compression. Don't really need to switch compression live in the same way as you quite often use boost whilst I'm playing. And this one is going to replicate the relay. So there is only really 8 switches, and that just about maxes out what a Nano can do anyway. If you're going to have switches and you're going to have indicating LEDs, there's not too many control terminals left. I think 1 or 2. I'm not using D13 because that, I think it's okay, but people say avoid it because it's linked to the LED, the built-in LED. Not sure about that. And pins A6 and A5 and A6 are analog only. You can't set them up as digital inputs, outputs. So I think there's only really 1 or 2 control terminals left. So the other difference with this unit is one of these switches is not going to. I'm going to lose patch 7. I don't really need. I could probably get away with 6 patches, to be honest, but I'm going to lose patch 7 and in replace it with a switch to do bypass. So I think this is the last step in the test bed. We built it, did the code, and shown a practical example. Shown how it works with my pedal board. Substitute the pedal board for any MIDI device you want to do, however you want to do it, and go from there. Yeah, the thing to note is the way, and you'll see in the code, I'm not strictly using these switches like flip-flops, like an on-off, on-off, like that. I will do that with at least one, with the bypass switch in this unit. They're cycling. They're an array of switch. So you'll see that in the code. You can set them up any way you want, and that, I think you'll see if you get that far, the difference between the code for this test bed and the code I'm going to use for this unit. You can see how you can adapt what's here to another purpose.